Since I messed up the number 6 on the sample test, I'm going to redo this. So this is for unit 4. So I didn't read carefully. I was really late that night. Anyway, 5,000 is invested in an account at an interest rate at 3.5%. And it's going to be compounded monthly for 12 years. And this is the compounded n times a year. So this is the formula. The amount after some time is equal to the starting amount. Let's see, we started with $5,000. Parenthesis, we get 100% of it back plus interest rate in decimal 0.035 divided by how many times we're going to get it compounded? 12 in a year, because you're going to get interest added each month. So then we're going to have to go multiply by this for each of the months 12 times, and then 12 times for each year, and there's 12 years, so we've got to go times 12. So we're going to calculate this on my calculator. I'm going to go with 5,000 parenthesis 1 plus 0.035 divided by 12 to the 12 times 12, or 144, and that's $7,605.16, rounding it off. Next one, what I missed was compounded quarterly. So now the n in the formula is 4 times a year, so we're going to have to multiply by this 4 times for each quarter. So, and how long to get to be 8,000? Starting at 5,000, so A0 is still 5,000. 1 plus 0.035 quarterly times we don't know how long to get it to be 8,000. So I'm going to divide by 5,000 on both sides. And I believe that is 1.6, just so you can see it. 1.6 equals, and the reason I'm dividing that out first is I want to get it down to a single base. And what is this base? 1 plus 0.035 divided by 4 is 1.00875. To the 4t. Once I have it as a single base, I use rule number 1 of logs because I'm trying to solve for a power. And the base is this, so it's log with that base of 1.6 equals 4t. So whatever this number is, I divide it by 4, and I've got the time. So let's figure out this number. Now I can go on my calculator to, to the math and find where I can change the base, or I can just go log of 1.6 divided by log of that last answer, 1.00875. But since it's on my calculator already, I could just use it, and I get that it will take, that's what this number is, 53 point whatever, and I have to divide by 4. So 53.949 divided by 4. I'm just going to go divided by 4 on my calculator, and it comes out to be 13.487 years. Roughly 13.4 years. That's the time it takes to go from 5,000 to 8,000. Now it says we're going to compound daily. That's more often, but we got to get it to double. So the amount at the end has to be the 5,000, 1 plus the same thing here, except for 0.035 daily, 365, to the 365 times the number of years. And we're trying to find out how long, how many years does it take for it to double. So I can either put 10,000 here, divide by 5,000, I get this has to equal 2, or I could have said, I don't care how much I started with or end with, I got to double whatever that start was, so this has to be 2 times this to double it. Divided by 5,000, I would have got 2 equals this. That's the same thing. So we got to solve 2 equals, and this in decimal is 1 plus 0.035 divided by 365 is very close to 1. And instead of writing all that down, I'm just going to say it's 1 plus 0.035 divided by 365 to the 365t. I have it to a single base. That base is that number, but I'm trying to solve for a power, so I go to log. And if that's the base, I can go log to that base 1 plus 0.035 over 365 of 2 should give me the power. So I got to figure this number out and then divide it by 365. So let's figure that out. And that's going to be simply, get it where you can see it here. Oh, yeah, you can see it. So I got to do, without going to the change of basing, I can just go log of 2 divided by log of, I work that base out right there, so that's my answer. And that's this number. And I have to divide it by 365. So divided by 365, and I get an answer of 19.8, and I'm solving for time, which is years in this here case. So it took 13 years to go from 5,000 to 8,000 up here. And we were only compounding quarterly. 12 years, it got to almost to 8,000. 8,000 took a little bit longer, 12, 13, but to get to 10,000, it should take longer than this, which this is. 19 is longer than the 13. And now, if I compound continuously in 12 years, I should get a little bit more than 12 years compounded monthly. Or, yeah, the other ones we were solved for time. So let's figure out what this one is. That's the other formula. The amount after some time is the starting amount, A0, A at time 0, E to the interest rate that it's increasing by, which is 0.035 times T, which in this case is 12 years. So all I have to do is type this one into my calculator. 5,000 e to the 0.035 times 12. Where did we do 15? 12. And I get $7,609.81. And that's is a little bit more than if I just compound it monthly up here.